in just 8 minutes. Let's leverage the Hxro Network Dexterity SDK to create and fund a trader risk group, and then place an order on a specific product within a market product group. So when it comes to DeFi on Solana, specifically things like derivatives, I'm a huge fan of Hxro Network. In simple terms, the general description that Hxro tends to use is that they're the liquidity layer powering on-chain derivatives applications. I figured that this episode of Byte-Size BUIDLing would be the perfect opportunity to dive into their Dexterity SDK. Specifically in today's video, we're going to go through the process of number 1, creating a trader risk group. These are called TRGs. Essentially, these are user or trader accounts on an MPG. And an MPG is a market product group, which again, in very simple terms, is just a group of products that derive from the same market. So we'll go through the process of funding the TRG and then placing an order on the desired MPG. Before we dive into it, let's quickly set some expectations about the code that we'll be writing today. The script will be split into 3 main parts. So the goal here is to create a TRG assigned to the BTC/USD MPG, but specifically assigned to the BTC/USD perpetual futures product. Once we create the TRG, we'll build a function called deposit or withdraw. This function will allow us to either deposit or withdraw funds within the TRG. And then finally, we'll create a function called place order. As the name suggests, this function will allow us to essentially place an order on the order book for the desired product in the desired MPG through our TRG that we opened previously. And huge thanks to the Hxro team for providing me with the script today. The majority of the script was derived directly from their documentation. So let's go ahead and get started. So first we'll need to import a few base libraries. To start, we'll need Solana Web3.js. Of course, as usual, this will be used as our foundational connectivity layer with Solana. Additionally, we'll need the Dexterity SDK from Hxro Network. This will be the main library that we use within the script. We'll also need to import wallet from Anchor. We'll need this to create a wallet object that we eventually pass into some functions from the Dexterity SDK. And then as usual, we'll also need base58 to decode our string private key and convert it to a uint8 array. And then of course in this case I'll be using .env to manage my private key. Also, for the sake of readability, I'll be casting Dexterity TS into a variable called Dexterity. To start, I'm going to wrap the entire script in an asynchronous function. The reason I'm doing this is so that I won't have to wrap the TRG creation in its own function. Before we do anything, we'll need to define a variety of different constants. The first of these will be our RPC URL. In this case, I'll be using a Solana DevNet node from Chainstack. So let's quickly head over to the Chainstack console and launch one. Alright, so I've logged into my account on Chainstack. I'm going to head over to my test4 project here. Then I'll start the join network process. I'll select Solana and then Solana DevNet. I'll keep this all default, and I'll deploy the node in Ashburn on Chainstack Cloud. And finally, I'll click Join Network. All right, now we can open it up here, then scroll down and copy the HTTPS endpoint here. Now we can head back to the script and paste it into the RPC constant here. All right, so now that we have our RPC endpoint defined, we can move on to importing our wallet. We can define this in a variable called keyPair, and then we can set that equal to web3.keyPair.fromSecretKey. And then in here, we can create a new uint8 array. And then of course we can call base58 and then the decode method. And then finally we can pass in our private key. And so now that we've defined our key pair, we can go ahead and create a variable called wallet. This will very simply be set equal to a new instance of the wallet object that we imported from Anchor. And then we'll pass in the key pair that we just defined. Okay, so now with all of our Solana related base variables defined, so our RPC, key pair, and wallet, we can move on to defining some base variables for the Dexterity SDK. To start, we can define MPG. Again, this is the market product group that we'll be defining our TRG within. In this case, I'll be using the BTC/USD market product group. Additionally, we can define a variable called product name. This will be set equal to the name of the product within the MPG that we're going to be trading on. In my case, it'll be BTC/USD perpetual futures. All right, so perfect. We now have all of our base variables defined. Let's move on to creating the TRG. To start, we'll need to create a variable called manifest. We can set this equal to await dexterity.getManifest. And then we can pass in our RPC. We can have it use caching, so we'll pass in true. And we'll pass in our wallet object that we previously defined. We can now use the manifest object to create the TRG. We can save this in a variable called TRG, and we can do await manifest.create TRG, and then new web3.public key, and then we can pass in the address of the MPG that we previously defined. So now with our TRG created, we'll need to go ahead and fund it. Let's do this in a function called deposit or withdraw. And then we can set this equal to async, and then amount number, and then we can also take a parameter called type, and that can be either deposit or withdraw. Let's start by creating a constant called trader. This will be a trader instance that we derive from the TRG. So we can set this equal to new dexterity.trader, and we can pass in manifest and TRG. Next, we can create a variable called n. In this case, we'll need to cast the amount into a fractional type. So we can do this with dexterity.fractional.new, and then amount and 0. Let's also quickly add some functionality to connect the trader account and print the balance. We can do this with await trader.connect, and we can just do async and open up that function here. Now we can simply log the balance. Additionally, let's quickly define a callbacks object. And in here, we can define a few general callbacks. We can do onGetting block hash function. We can do onGot block hash function. And finally, we can do onTX send function, which in this case we'll want to use as an opportunity to print out the signature of the either withdrawal or deposit transaction. So we can do signature of any type and then do console.log and then log out all of the information here. Okay, so next we can go ahead and define the individual deposit or withdrawal logic. Let's start by just doing a simple conditional by checking if the type is deposit. If it is, then we can do await trader.deposit and then n, which is the amount, and callbacks. Alternatively, if the type is equal to withdraw, then we can do await trader.withdraw, pass in n, and we can also manage our callback here. All right, so we've just defined the deposit or withdraw function. We initiated a trader object, converted the amount, printed the balance, defined the callbacks, and then handled either a deposit or withdrawal. Before we move on to the final part, let's quickly call the deposit or withdrawal function, and let's deposit 10,000 UXDC. So now let's define our final function. This will be place order. We can do this within a constant called place order and set it equal to async. And then again, similarly to the previous function, we can do type of either buy or sell, set price equal to number. We can take a price parameter of type number, a size parameter also of type number. This function will essentially place an order on the order book for the desired product within the MPG that we defined. In this case, that'll be BTC/USD perpetual futures. And same with the last function, we can start by defining our trader object, which will be new dexterity.trader and then manifest and TRG. Let's also go ahead and connect to the trader, and we can go ahead and print out the balance, as well as all of the current open orders, the positions value, and the P&L. Additionally, we'll need to get the index of our desired product from the array of products within the MPG. Again, in this case, our desired product is BTC/USD perpetual futures. Let's do this by first defining product index as any, and then opening up a loop here, and then looping through all of the products present within the MPG. Now we can quickly open up a conditional. Here we can check if the name of the product within the current iteration matches the name of the desired product that we're trying to trade with. So we can just simply do name.trim is equal to product name.trim, in which case we can set product index equal to index. And then if that is the case, then we can break the loop. And we'll also need to convert the price and order size to a fractional type. So we can start by defining a variable called quote size and setting that equal to dexterity.fractional.new and then pass in size and 0. And then additionally, we can define a variable called price fractional, which in the same way as the above, we can just do dexterity.fractional.new and then size 0. Additionally here, we can define the same callbacks as we did in the other function. It's just that in this case, we're changing the language a little bit to refer to the order rather than a deposit or withdrawal. We can go ahead and define the logic for either buying or selling. We can start by simply doing if type is equal to buy. Then we can do await trader.new order, then product index. We can do true for the parameter is bid. We can set the limit price to price fractional. Then we can pass in quote size, then true. And then we can just set these remaining parameters to null. And then finally, we can define our callbacks. For the sell functionality, we can just go ahead and copy this, then paste it below, check if the type is equal to sell, and set isBid to false. And finally, to test it, we can just go ahead and do place order, and then we can do buy 30,000 and 100 order size. At this point, we've imported all of our base libraries, defined all of our base variables, created the manifest and TRG, created the deposit or withdraw function, and created the place order function. So let's go ahead and run it and see if it works. And as you can see, it looks like it worked. We have the successful deposit of 10,000 UXDC, as well as the successful placement of our limit buy order. This was episode 18 of Chainstack's Byte-Size BUIDLing series. If you'd like to watch the 17 other videos just like this one, then you can do so through the link below. Additionally, within this video, I spun up a Chainstack Solana DevNet Elastic node. If you'd like to use Chainstack for your own project or just learn more about Chainstack Elastic nodes, then you can do so through the link below.